10,000 watts for 50 bucks, 150 dB with a single 8-inch, better sound quality with a $6,000 power cable, amplified claims and exaggerations are all the rage. You know, science. We'll dig in over what manufacturers say with their marketing language and what they say by not publishing certain specifications. As armchair engineers, dissecting their product to discredit all that mumbo jumbo is what we're gonna do. To start this series, I'll kick it off with the Dual ALB12. This is a 12-inch 300-watt ported subwoofer system with built-in amplifier. For the money, this isn't a bad product. However, when reviewing the ratings, a couple of things stand out. The first and arguably most important is the 300-watt max 100-watt RMS internal amplifier. Considering this unit sells for roughly about 100 bucks, there is virtually no room to spend on sufficient amplification. The components consist of a 12-inch driver, a ported subwoofer enclosure wrapped in vinyl, metal bar speaker protectors, and a 100-watt amplifier. In today's retail world, the actual manufacturing cost for an item like this would be in the $30 to $40 range. A simple breakdown of our component costs for each part would be $10 for the driver, $10 for the enclosure, $15 for the amplifier, and roughly $2 for miscellaneous parts. Then we have to add in the manufacturer's margin. With these minimal costs, I need to begin to question the truth in the specs. We are using off-the-shelf equipment, and this is hardly scientific, but it does give us insight into the design of this system.
I know you told your friend you're not okay, and tell me what's wrong and why you never said you felt that way. And guess you're trying to stay strong and fake a smile until I look away. But I've known you too long, it hurts to watch your blue eyes fade to gray as you fade away, as you fade away.
Yeah, I'm about to fade away, cause every time I wake up I feel like it's Monday. Something's going wrong with all the chemicals up in my brain. All of a sudden I don't look at anything the same way. Got a buildup of my thoughts sitting in an ashtray. I'm sorry that I'm so inconvenient, okay. Just let me be me and I'll stay out of your way. I can see the way you look at me, I'm such a disgrace. I never really asked to be brought into this place. You wanna love me? Well then baby have a taste. All the highs and the lows, no you'll never be.
There is some. The port is tapered and rolled to prevent port noise. The subwoofer has a vented pole piece and a magnet structure designed to handle roughly about 100 to 150 watts. Overall, I was moderately optimistic. Based on a visual of the amp, there's no conceivable way this amp can produce 100 watts RMS. There are only 2 output devices and the power supply looks completely undersized. Testing the amp will give us a better idea as to what the limitations are. I suspect the manufacturer is using a non-linear box tuning to artificially raise the output of this enclosure. The oscilloscope leads, audio analyzer, and voltmeter are connected to the 4-ohm dummy load. The volume on the iPhone is set to max volume and a 40Hz test tone is used. With all the test leads connected, we verify that our signal and testing equipment are matching in their voltage. Since our testing setup doesn't have a power supply and only a battery, we test battery voltage to ensure our amp is receiving enough input current. We turn up the volume to clipping at 20 Hz to 80 Hz and save our results. At clipping, the amp has an output voltage of 14.2 volts at 40 Hz. This amp at best is 50 watts RMS. Suspecting something may be wrong, I checked the battery voltage again to demonstrate power drop under load to make sure the amp isn't suffocating. To demonstrate what amplifier clipping sounds like, an audio setup was configured to record the sound of distortion. To figure out if there was a non-linear response, the system was reassembled, and our mic was placed about 10 inches from the cone. Using test tones from 20 Hz to 80 Hz, the SPL outputs were documented. To verify our in-room results, we wanted to test in-car. To test the SPL output in-car, the same setup was used. Our audio analyzer for tone verification and SPL output. The voltmeter was configured to monitor battery voltage, and the iPhone with Kicker U app was used for test tones. The analyzer microphone was placed in the driver's seat, and we began our SPL tests. So our initial suspicion of a nonlinear box tuning is contributing to the max output. To plot the frequency response, an impedance sweep of the driver was done. The known mass method was used for VAS testing. To figure out our internal enclosure airspace and port vent area, we measure the enclosure and port area. Using a little math, internal volume was calculated. We got roughly between 0.75 and 0.8 cubic feet. To verify our airspace, we filled the enclosure with packing peanuts and measured the volume. The driver parameters and enclosure airspace with port area were entered into wind speakers. A plot was constructed demonstrating the response in free air and in car. We confirmed what we suspected. There's a 10 decibel bump at 75 Hz that tries to make up for the lack of amplification. A 10 decibel bump is like adding 3 times more power, giving you a theoretical max output of 300 watts. Who wants a subwoofer with a bumped output at 75 Hz? It also demonstrates that this subwoofer is underpowered and not near its physical excursion limit. As with any design, there are limitations, and clearly cost and woofer size were the 2 key marketing parameters. The design of the system is meant to overcome the most expensive part of most systems, the amplification. We've supplied a Google Doc with all the captured parameters, and the link is in the bio with the internal volume, subwoofer parameters, output voltage conversion, and amplifier output differential based on input wire size. This video is not meant to all over this subwoofer. It's meant to show the limitations manufacturers face when marketing departments, system architects, and accounting come together to build a product that must hit a price point. Had they spent another $10 at the manufacturing level, this product could have been so much better value. I would have spent it entirely on the amplifier. Hopefully this video helps you see how systems are engineered and provides insights into claims that manufacturers make and how they technically get around this. Next up, we'll take $12 and see if we can improve this product. Hopefully we don't smoke it. That's it on this version of manufacturers say. Be sure to get all of your car audio and video gear with us at qualitymobilevideo.com. Don't forget to subscribe to our channel if you haven't. Click that like button, join the conversation below, and follow us on Instagram at qualitymobilevideo. Thanks for watching.